Welcome to Excellent Grades Academy. This is Dr. Byson EM. Today we are doing alcohols. Okay, we're doing alcohols. And under alcohols, we're also going to solve tutorial sheet 3. Let's get into this video. So tutorial sheet 3, question 3 and question 4. Okay, so alcohols. A very important topic. So what are alcohols? What are alcohols? So these are organic compounds. Organic compounds that contain one or more hydroxy groups. One or more hydroxy groups. So an hydroxy group is just an OH as the priority functional group. So as the priority functional group. As a priority functional group. Okay. So if you have a hydroxyl group attached to an organic chain, this is an alcohol. Okay. So this is an alcohol. So what you need to know is that an alcohol, the oxygen on an alcohol has got lone pairs of electrons. These lone pairs of electrons are the ones that serve to function mostly in the chemical reactions of an alcohol. So these lone pairs of reactions act as bases and they also act as nucleophiles in lone pairs of alcohols. So it's very important that you understand that. Okay. Now alcohols are classified. So let's look at classification. Classification of alcohols. So alcohols are classified as primary alcohols. So classification. They're classified as primary alcohols, secondary alcohols, or tertiary alcohols, depending on the carbon that they are attached to. So if we start here, this alcohol here is a primary alcohol. Why? Because the OH is attached to this carbon here. This carbon here is a primary carbon. This alcohol here is a secondary carbon. It's a secondary alcohol. Why? Because the OH is attached to a secondary carbon. But then when you have this group here, this is a tertiary alcohol. So tertiary. Why? Because the OH is attached to a tertiary carbon. So this is a secondary, and then this is a primary alcohol. Okay, now let's look at the chemical reactions that alcohols undergo using the questions that were provided in the tutorial sheets. So question 3 was saying, give structures for R and S and write detailed reaction mechanisms for the following. So this is an alcohol here, and on this point here, we've got a stereoisomer. Okay, this is a stereoisomer. This stereoisomer is an R configuration. Okay, the alcohol here is in front. The OH, which is the functional group for the alcohol, is in front. And then this is what we call tosylate chloride. So tosylate chloride in pyridine acting with an alcohol. And then the product that you get here, you react it with potassium cyanide. So we're going to see how this reaction takes place. Okay. So this is the question. So an alcohol here, this is a cyclic secondary alcohol. Why? Because this one here is a secondary carbon. Okay. So this structure here that we see here, this is the structure for tosylate chloride. So you have to know the structure for tosylate chloride because this reaction mechanism is very important. So what is going to happen is that the oxygen, which has lone pairs of electrons on the alcohol, is going to attack the sulfur of the tosylate chloride. When that happens, one of the oxygen double bonds to sulfur is going to break. When that breaks, you're going to have this chloride here. Okay. Now, oxygen is not comfortable having a negative charge here. So this double bond this bond that broke is going to reform. So it's going to reform. When it reforms, it's going to kick out this chloride here. Okay, so when that chloride is kicked out, this is the products that you are going to have. Okay, now remember, when the oxygen attacked the sulfur, it formed 3 bonds. Now when oxygen forms 3 bonds, it becomes unstable, so it assumes a positive charge. Okay. Now the pyridine in solution, this is the structure of pyridine here. The pyridine in solution is going to use its lone pairs of electrons on the nitrogen and is going to get the excess hydrogen that is bonded to the oxygen, and these electrons that are attaching the oxygen and the hydrogen is going to break to the oxygen to neutralize this positive charge. So this is the products that you are going to get. Okay. This is the products that you are going to get. Okay. Now, this is the product R. So this is the product here that they wanted us to get. Okay. This product would then react with potassium cyanide here. So this is simply potassium cyanide. Okay. So now let's see how the potassium cyanide reacts to the alcohol. So the potassium cyanide has got a nucleophile. The cyanide part is negatively charged. This negatively charged here is going to attack this alpha carbon here, because this alpha carbon here is partially positive. So it's going to attract the negatively charged cyanide, and this whole group is going to leave. So because this group was in front, and this is an SN2 reaction, the cyanide that is going to form here will be behind the compound. So this is how product S is formed. So that's how that reaction mechanism takes place. If you want to predict the product, when an alcohol, let's use this same alcohol, like this, reacts with tosylate chloride in pyridine, what happens is that the H is replaced by the TS, like that. So this will still be in front. The configuration of the isomer won't change. The H of the hydroxy is going to be replaced with a tosylate there. So this tosylate is a very good leaving group. Okay. So the cyanide in solution, which is negatively charged, is going to attack on the tosylate, and this is going to leave. So because this is an SN2 reaction and the tosylate was in front, the cyanide is going to go at the back, like this. So that is, in a nutshell, how that reaction happened. That is the reaction mechanism. Number 2, we are reacting an alcohol with an acid. So this is hydrobromic acid here. So hydrobromic acid. So we said that the lone pairs of electrons on the oxygen of the hydroxy serve as a base. So they will come and get the hydrogen from an acid, which is the proton donor. And then these electrons are got by the halogen. So this group then will be protonated. After its protonation, it's going to leave on its own. After it leaves, there's going to be formation of a carbocation here. Now this carbocation is adjacent to a tertiary carbon, so there's going to be a hydride shift. So this one here is a hydride shift. The hydrogen is simply shifting. So this hydride shift is going to shift the carbocation from a secondary carbon to a tertiary carbon. And then after the carbocation is formed, this negatively charged bromine in solution that remained from the acid is going to attack the carbocation and form this product here as a major compound. But of course, this product here is going to form as well, because before the carbocation shifts, this bromide, the negatively charged, might attack it there. So this is going to form as a minor product. Okay, so this is how the reaction mechanism happens when an alcohol reacts with an acid. What happens if you react an alcohol with SOCl2? So this is known as sulfonyl chloride. Sulfonyl chloride. So below here is a reaction mechanism. This is the structure of sulfonyl chloride. This one here. So the lone pairs of electrons on the oxygen will attack. So it will attack the sulfur on sulfonyl chloride. This bond is going to break. If that bond breaks, this is what you're going to form. But then this bond, the negatively charged electrons on the oxygen are going to reform this bond here. And then it will kick out one chloride. One chloride. And then pyridine in solution is going to come and get the excess oxygen, the excess hydrogen on the oxygen here. You know that when the alcohol attacks and forms a bond with the sulfur, there's always an excess hydrogen that remains, so it makes it positively charged. So the job of pyridine is to come and get this hydrogen and neutralize this, so it remains like this. Then the chloride that left is still in solution, this chloride here. This chloride that broke off at this step here is going to come and react in an SN2 reaction. React at this carbon here that is connected to carbon and kick out this entire group here. So this entire group is replaced by the chloride, like this. So this is the reaction that takes place when you react an alcohol with sulfonyl chloride. Just know that the OH is replaced with a chloride, one chloride from the sulfonyl chloride. That's how it happens. Number 4, what happens when you react an alcohol, so this is an alcohol, with phosphorus tribromide. So this is phosphorus tribromide, which is denoted as PbR3. So what will happen is that the lone pairs of an oxygen are going to attack the phosphorus, and then one bromide is going to move out. This bromide that moves out is going to come and attack on the alpha carbon here. The alpha carbon is the carbon that is attached to the OH. Okay. And then this will kick out the entire group. So the OH will be replaced by a Br from the phosphorus tribromide. So always remember, when you react an alcohol with phosphorus tribromide, what happens is that the OH is replaced by a bromide. Simple. And this is the reaction mechanism that goes on. What happens? So we've already looked at this mechanism. So this is an alcohol reacting with tosylate chloride. Okay, tosylate chloride. The lone pairs of electrons on the alcohol are going to will react with the sulfur on the tosylate chloride. This bond here breaks, and then this bond reforms, kicks out one chloride. So kicks out this chloride here. And then the pyridine, so this is the pyridine in solution. The pyridine will come and get the hydrogen that is making the oxygen here positive. All right, and then this is going to form. Okay, so whenever you react an alcohol, any alcohol, say this is an alcohol here, you pass it in tosylate chloride and pyridine. The H here will be replaced by the TS, tosylate. This is a very good leaving group. So if you have a species in solution like cyanide, this cyanide will act here on this carbon and this group will leave in an SN2 reaction. So what you create is this. So always know the reaction mechanism when an alcohol reacts with tosylate chloride. It's an important one, and it will be there in your tests. F5, we've looked at this already. An alcohol reacting with phosphorus tribromide. All right, this is what happens. The lone pairs will come and attack here. One bromide leaves, forms this very good leaving group here, and then the bromide in solution will come and attack from the backside in an SN2 reaction, and this is the product that is formed. Okay, now let us look at these mechanisms. So what happens if you react an alcohol in these reagents? What will happen if you react an alcohol in these reagents? Okay, let's look at the reaction mechanisms. Okay, so this is called chromic acid. When you react an alcohol in chromic acid, what you are going to get is the formation of a carboxylic acid. So this is a carboxylic acid that is formed. So always know this. So know the reagent that reacts with an alcohol to give you a carboxylic acid. Okay. Now, what happens when you react an alcohol with PCC? What happens when you react an alcohol with PCC? So PCC, this is the structure here. So this whole structure, this is the structure for PCC. So what will happen is that the lone pairs of electrons on an alcohol will come and will attack the chloride. Okay, the carbon. This carbon will cause this oxygen bond to break and then form this product here. And then this oxygen bond that broke will come back and reform and kick out one chloride. So after that happens, then you're going to have this product here that is formed. And then this negatively charged oxygen, because it has 3 lone pairs of electrons, will come and get this extra carbon here from the oxygen, and this bond will break. This bond will break, and then it will neutralize the positive charge on the oxygen. After that happens, it will form this product here. And then the chloride that left in solution, okay, this chloride that left in solution is going to get this hydrogen here, which is an acidic hydrogen, and then these electrons will collapse, and then this here is going to leave, and it will form an aldehyde. So you react, when you react an alcohol in PCC, what you end up forming is an aldehyde using that reaction mechanism. Okay, if you react an alcohol in chromic acid and sulfuric acid, you end up forming a ketone here. So what is important is knowing the reaction reagents that react with an alcohol to come up with a certain product. Okay. Now, what happens when you react an alcohol in POC3? Okay, so this is the structure for POC3. So the lone pairs of electrons on the oxygen of the hydroxy of an alcohol will attack the phosphorus. This bond will break, then form this structure. This bond will come and reform, kick out one chloride. When that happens, the pyridine in solution will use its lone pairs of electrons, get the excess hydrogen on the oxygen that makes it positively charged, and then give it its electrons to neutralize this positive charge here. And then when that happens, the pyridine again will come and get this acidic hydrogen here, and this hydrogen will form a double bond here and will kick out this leaving group. So what you have is an alkene. So an alkene is forming when an alcohol reacts with POC3. POC3. So just follow these mechanisms. They're quite simple. Revise them, know them. They're quite important. Let's look at question 4. They're saying, consider the formation of the following compound. This is an ether from an alcohol. So this is the reaction mechanism. Okay. So you're forming you are getting ethanol. So this is ethanol. And you are forming an ether. Okay. So now remember that what you are forming, an ether, has got 2 times the carbon of an alcohol that you have here. So meaning that there are 2 alcohols in solution. So 2 alcohols. The first step that you take is you react an alcohol with sulfuric acid. Okay, so this is acid catalyzed. The lone pairs of electrons on the oxygen, remember I said they serve as a base. So they will come and get 1 hydrogen from sulfuric acid, become protonated. This protonated group leaves on its own. After it leaves, another ethanol will come now and attack on the carbocation using its lone pairs of electrons. And then that will form this. But the oxygen here is attached to 3 things, so it is positively charged. The conjugate base that was formed from the acid will now come and attack this excess hydrogen, break this bond on the oxygen, and form this ether here. Okay, so that is how the ether, the diethyl ether, is formed from ethanol. Here they're saying, how can you get these products when you react methanol with an alkyl halide? So for alkyl halides, we've already done these reactions. You can watch this video on alkyl halides that we've already uploaded on this channel. The link will be in the description and in the comment section. Okay, so just follow this mechanism of how this is happening, and then you're going to see how these products are forming from this reaction here. In this video, we're focusing on how alcohols react. Okay, so what happens if you react an alcohol in sulfuric acid at a high temperature? It forms an alkene. So it forms an alkene. So the reaction mechanism for this one will be this. So this alcohol here has got 2 lone pairs of electrons, and it's reacting with an acid. So these lone pairs of electrons will attack the hydrogen, and then this will be protonated because the oxygen will be attached to 3 covalent bonds, so it will be positively charged, and the conjugate base, which is negatively charged in solution. This will leave on its own and form a carbocation here. All right, carbocation. And then this conjugate base will come and attack this acidic hydrogen. And then these electrons will collapse to here, forming the alkene as a product. So that is how the alkene is formed, from heating an alcohol in hot sulfuric acid. All right. So this is an alkene. We've already done the mechanisms of alkenes. All right. So those were the reactions of alcohols in tutorial sheet 3. I hope this video helps, and all the best in your test on Sunday. All the best. Go and charge that test. Okay? See you in the next video.